This is video number 3, lesson 1, vertical and horizontal translations. What is a translation in math? Translation definitely have various meanings in different contexts. However, in math, when we say translation, we refer to just moving an object from a place to another. Let's say that something was here, it just translated to that location. So it just moved from one place to a different location. Now, as far as we're concerned here, we would be talking about two directions: moving a graph vertically and moving it or shifting it or translating it horizontally. Let's use my basic parabola. Remember, y equals x to the power 2. This is the parent of them all. So that's the basic parabola, y equals x squared. I want to move this graph or this parabola upward, down, left, or right. I have to apply simple translations. I'm going to start with the vertical ones. Applying a vertical translation, I'm going to show you directly what does that mean. So y equals x squared, for example, x equal 1, 1 squared is 1. That is the value of y. X equals 2, 2 squared is 4. So this is the point, 2 and 4. And so on. So if, let's say I want to move all the points, remember this has like billions of points on it, like see like all those points. So if I added one value, if I added 1 to all those points, to the y values, so this point was negative 1, 1, let's say. If I want to move this point from this location here to here, so I'm adding 1 to the y values, simply add 1. And all those points would move. The graph would shift upward, so 1 is added to all the y values. And that is called a vertical translation, because all the points for all the values of x here are just shifted 1 unit up. Let's look at our basic curve, original one, y equals x squared. That was my basic curve. You see this point here, negative 1, 1. Okay, let's zoom on it. Okay, that's negative 1, 1. Now, it moved up by 1 unit, 1 square. So if you look at the x value, it's still negative 1, the x value, the x coordinate. However, y is 2. So same x values, but all the y's, we add 1 to them. So for example, at the green curve, the original one, negative 2 was 4. Now I would know that, I would anticipate that for the blue curve, which is the transformed curve, for x equals negative 2, it's only shifted 1 unit up, so it's going to be 5. So it's negative 2 and 5. Similarly, like here, I know on the green curve, that curve here, the original one, the parent one, negative 2 was 4. That's the point, 2, 4. And we have billions of points again. We're talking about this in particular. So applying this vertical translation shifted this point from here to here, and this point again is 2 and 5. So same x value, but the y value is just shifted up. Now, since we can add numbers to shift up, then consequently, if I want to shift it down or move it down or translate it down, I'm just going to subtract numbers. So again, that's my original one, x squared. just subtract 1 here. This graph is gonna shift down all the points, all the y values. So this was the vertex 0, 0. What would you expect the new vertex would be? X is still 0, yes, but the y value now is -1. So it is 0 and -1. That is a vertical translation. Now, what about horizontal translations? How would we think to move it left and right, like moving it up and down? Okay, that was an easy task. Just add or subtract or take away values for y. Then the graph would shift up or shift down. Now, to delete this, that's my original graph. To shift it left or right, we think about the zeros or the x-intercepts. Here, this is a particular case. We have only one zero, which is the vertex 0, 0. So I'm gonna shift this 0 or this x-intercept left or right. Imagine this equation as x minus 0 squared. Remember the factored form? So x squared is technically x minus 0 squared. That's why it's here. Now, remember x minus r, x minus s. So that's the x-intercept. So if the x-intercept here is 0, then that's the vertex here. So if I want to move it right, let's say I want to move it 2 units to the right, just type in 2 here, and you see it technically moved to the right. So by creating a factor, writing the equation in a factored form. Remember, minus is from the equation itself, the minus sign, and this is the new x-intercept. Okay, what if I want to use it? What if I want to move it to the left? That's my curve, x minus 0 squared, which is x squared. If I want to move it here, this direction, so this number here should be negative. So -5, let's say -2. So it's x negative -2. It just moved or translated to the left. Now, technically, we do not write x negative -2. We just substitute that by writing plus. And that is shifting the graph to the left or to the right. So again, just say, let's say you want to shift it 3 units to the right. So minus is from the equation itself. I want it to come here. That is 3. So I just put 3. It just shifts there. Let's say I want to move it only 1 unit, but to the left. I want it to come to -1. So I just type -1 here, and it just comes there. And just for simplicity purposes and writing things in simplest form as we like in math, we just type plus here instead of negative, because negative times negative is positive. That is the horizontal translation. Now, can we do both together? What do you think? Can we apply a horizontal translation and a vertical translation at the same time? So like moving left, right, and then moving it up? Yes. Technically, yes. Because we can move it left, then up, or I mean right, then up, or down, then left, or left, then up. So you name it. So let's go back to our original graph, x minus 0 squared. So let's say I want to shift this 1 unit up. So just add 1. It shifts up. I want to then, the next step, I want to move this 2 units here. So I would type -2 here. Then my graph was here. Then it went up by 1. Then it went down. I'm just going to graph them step by step. So that's y equals x squared. That's the original one. we shifted it up by 1 first, so y equals x squared plus 1. So that's the black curve. It just moved 1 up, and finally we moved this black to the left by 2 units, and that is the final transformed form. Now, order here does not matter, so we can just move up then left, or we can start by just moving it to the left and then taking it up. Order here does not matter, and that is applying vertical and horizontal translations. So I want to just wrap up my video by saying or integrating the concept that we've learned in the previous video about the stretches and compressions. So let me delete this, delete that. So this is my transformed curve. It was here, it moved there. What if I want to make this transformed curve wider or narrower? Can I do that? Definitely yes. Remember, if I want to make it narrower, multiply it by a number greater than 1, let's say 5. It's narrower. Multiply it by a number less than 1, so like 0.5. Now it went wider. It started here, it moved 1 up, it moved 2 to the left, and now we can apply translations. This I mean vertical compression here. And this is the transformed curve or transformed parabola. Now let's write it in a more technical way. That would be plus 2. Next, let's say I don't like it looking upward here. I want it to look downward. I think you know the drill. My same graph, I want it to look downward. Just let A be negative. And this is called a reflection, a vertical reflection. So it is reflected vertically or reflected on the x-axis, because that's making the A value negative. Removing the negative sign, now it's positive, so it's opening upward again. Now let's say I want to go back to my original position. Okay, here order would matter. Remember, this is 0.5, that's multiplication here. Remember, that's multiplication here. So if you remember BEDMAS, multiplication is stronger than addition and subtraction. So whenever you are going to do those in order, first we apply the vertical translation, I mean stretch or compression. Then we move left or right or up or down. But this thing should come first, vertical compression or translation. So let's delete this. Now we're back to the curve. I don't want it, if I want to move it back here, so just also get this out of the way. So now I'm back to my original place. Again, I want this to come down back, and that is my equation back here. Back safe and sound to its original location. Now, I want you to answer that question during the classroom here. There are some worksheets there. We're gonna work with those worksheets or try to solve them based on this concept, and you're welcome to watch this video again and again. And as I said earlier, you do not need to take notes or just pause the video and write whatever I was saying, because I have a summary that is uploaded to Edsby anyway, so you can go and check that anytime you want to do, let's say, a review or you want to solve a problem. And that would be it for this video. Thank you.